Three-phase induction motors. Three-phase induction motors are basically AC motors and perhaps the most widely used AC motors. Um, we discussed DC motors in detail, of course, and in the DC motors and DC generators, your armature where the in generators armature where the voltage is induced, and in motors where you supply current, so that the Lorentz force is applied on that moving part is of course part of the rotor which moves, and the field setup is part of the stator, where you set up the field by supplying the current or by electromagnet. Now three-phase induction motors is a little different. You have a stator where your three phases are connected, so the current is going to the static part of the motor, and then you have the rotating part, but you are not supplying current to the rotating part. How the voltage is induced and how the Lorentz force is applied on the rotating part, that's what the induction motors makes it different from the other motors that we have discussed so far. So we are going to discuss the basic principle first, and then we're going to look into how an induction motor works. When you apply a three-phase power supply, you connect a three-phase power supply to the static part of the motor. So first we're going to look at how, when you have a ladder-like network like you see in this figure 13, figure 13.1, if you have a ladder-like network which is made out of some conducting material, and you have a magnet, and you move a magnet on top of the ladder, as you can see, it is moving with a speed of v in a direction from left to right. So of course when we move the magnet, remember what's going to happen. The magnetic field is going to change with respect to time for each part of the ladder over which it is moving, of course, and when it changes with respect to time, then of course according to the Lorentz force of electromagnetic induction, some voltage will be induced in that part of the ladder. And now remember that this ladder is shorted out on both sides, and the whole thing is made out of some conducting material like copper or something. So now when voltage will be induced, as you can see, the magnet is moving right now. So when the voltage will be induced and it is shorted out, what's going to happen, that it's going to run a current. It's going to run a current, and depends in which direction voltage will be induced. For example, if it is moving in y direction as it is seen right now, and the magnetic field it is in negative z direction or negative k direction, then according to Lorentz force, F is equal to I L cross B, what's going to happen, or sorry, voltage induced is E is equal to L dot V cross B. So when you say in which direction voltage will be induced using L dot V cross B, V is in J direction and B is in negative K direction. So J cross K is I. So that's gonna give you negative I. I think I have right here, I have explained it somewhere anyways. So negative J, let's see, oh yeah, one thing I forgot to tell you. Although magnet is moving in J direction, but remember for L dot V cross B, when we used to evaluate that, we used to see in which direction your armature was moving, that is the part in which voltage is induced. So when magnet will move in J direction, then the part where voltage will be induced, of course, is going to be moving in the negative J direction with respect to the magnetic field. So that's why we're gonna take it as negative j, which is the relative velocity. So that's going to be negative j cross negative k. That's gonna give you I. And let's assume that voltage will be induced in I direction. So L dot V cross B, we're gonna take the length vector is in I direction. So I dot I is gonna give us 1. That is, the voltage will be induced in the positive I direction, that is coming out of the page, with respect to the negative I direction. So current is gonna come out of the page and then travel in both directions, as you can see in this figure. So let's say half of the current is gonna go left, half of the current is gonna go right, and then this is how the current is gonna flow. And now when current starts flowing, what's going to happen? Lorentz force is going to be applied on this. So F is equal to I L cross B. I L cross B. So direction of the length vector is in the direction in which the current is flowing. So L will be positive I, B is in negative K. So what will be the direction of motion? I cross negative K. So I cross K is negative J, and then since we have negative K, so negative J minus negative sign is positive J. So what's gonna happen? The ladder will start moving in the same direction in which you are moving the magnet. Hence, you can do this experiment at home actually with a conductor and create a network like this. If you have a magnet, you can move the magnet on the conductor and you will see that that conductor is going to start moving in the same direction in which you are moving the magnet. So this is a very interesting phenomenon, and you will see that the faster you're going to move the magnet, the faster that ladder network will start moving. But remember, it will never catch up with the speed of the magnet, because if it does catch up with the speed of the magnet, the relative velocity between the two is going to become 0, and the induced voltage is going to drop down to 0. If the relative velocity is going to become 0, induced voltage is going to drop down to 0, and as soon as the induced voltage will drop down to 0, current is going to become 0. When the current is going to become 0, force is going to become 0, and as soon as the force is going to become 0, then of course it starts slowing down. But again, as soon as it will start slowing down, relative velocity is gonna become non-zero, and then another voltage will induce, that will draw another current and a new force. So the velocity with which the ladder is moving is going to be close to the velocity of the magnet, but it will never catch up with the velocity of the magnet. So this is how a ladder network made out of conducting material can move when you move a magnet on top of it. Based on the same principle, your three-phase induction motor works. So the working of three-phase induction motor we will explain in the next video.